Welcome to this getting started video for the 3D Geocam software and the scale electric moulds. We'll start off by loading up the 3D Geocam, which we'll go to the import option and select import 3D Geocam. That'll give us the software in its minimised form. It's always nice then to maximise it, and the first thing that the software is looking for is for us to actually select an STL file to the machine. So we'll bring in browse, and I'm going to select the standard body mould. Open that up. Now you see initially the mould comes in on its side. What we need to do is we need to rotate that round by holding the left mouse down until the roof is about where we can see it, so the car's in a nice position. That's because you'll notice the blue effectively square. That is as the machine at the moment understands where we want to cut through the work. In other words, it actually would try and machine one that way up, so half the car would be missing and we'd just get the wheels and effectively like a side cut of the model. So what we'll do is we'll move it back to a reasonable position. That will just make sure that when we do come to set the cutting plane we know where we are. We'll move on next to defining the cutting plane, which is the next job. Now then, the way to understand this cutting plane is blue is effectively the top, that's the top of the table, and yellow is underneath. So as long as we're on the blue side, we can see we know that that's the top of the table. If we're looking at the yellow side, then that means that we're actually upside down. I'll give you an example of that. If I go over to the block now, I have a number of things that I can select, each one of these letters. I'll start by selecting D, and D means that I'm actually cutting the model upside down. The way that it's split the model is with the wheels or the wheel housings stood up in the air. So we'll put it back the right way up again. We'll try E. E splitting the car to end to end with the base facing us. We'll try C. C is splitting the car down the middle. Still not where we want it. And so we'll try B. Oh, I'm guessing this is absolutely this orientation we want to be. So we've got the car in an orientation we can understand, and that's allowed us to put the cutting plane in an orientation we can understand. The only thing that we're now doing is we're actually cutting the car halfway up. So it means that we'd actually end up with just the top part of the mould sticking out. So what we want to do now is alter that cutting height. We can do it on the slider, which means if you want it to cut down to a certain set of features, you can do. Or you can enter the number numerically. We're actually going to take it right down to 0, which means that we're machining this right down to the bottom of the of these arches, which gives us an extra bit of skirt around the side when it comes to the vacuum forming, just to ensure that the lip on that edge there is as deep as it can be. It's so much easier to take a bit off than trying to add a bit on. Right, we'll move on to the select material. Right, we don't want PCB, we're going to change that over to hardwood. And then the standard block size that we use at Boxford is 150 by 75 by 55. Now then, I am putting the whole block size in, which does mean that if we machine the whole way right down to the bottom of the block, we could potentially hit the bed. So it is important to make sure that there is part of that base is safe for the clamps to actually hold it, unless you're holding it in a different way to using the offset nuts. Right, that then puts our car in, and you'll notice that what it's done is it's actually put the car in as big as it possibly can within the shape that we've given it, which means that if we actually run that mould, we'd end up with a car that was a body that was too big to fit the chassis. It's actually made it 115%, trying to use the material as best as it possibly can. So what we'll do is we'll take that back to 100, so we now know that that car body will fit. Now then, it's temporarily disappeared. If we use the turn control, that will bring it back. so we can actually see the model coming in. If you did ever have a situation where your model was facing the wrong way, then what you can do is just use the turn control to face the vehicle the way you want it. Now then, at the moment we've got a certain amount of material around the edge that's actually not going to be machined at this stage, but of course from the point of view of vac forming we don't want that lip left up, so we will later on make sure that it goes right down to the base. Okay, so we're moving on to selecting next, which gives us, this is where we actually can alter where the model is inside the block. Now I'll purposefully put it that way up. The work shift at the moment is 10, if I take that down to 1, that allows me to push the model right up to one end, so that if we were actually grasping the model using a vice at this end, then we could make the model favour the far end, so that we were missing the vice jaws. So you can control quite easily where it is. In the same breath, if I took that up to 19, moves the model down that end. But for our purposes, we're going to be holding it on the table base using the offset nuts. We may as well keep it in the middle. And the same also from side to side. We can take that down to 0, or we can move it up to 10, move the model over either side. It was 5.5 to put it in the middle. If you ever do lose track of those, you can always touch the fit to center button, and that will move everything back into position for you, resetting the numbers. Now then, as standard, it's moved the model 0.3 of a millimetre from the top. That's just to ensure that it cleans up. So we do find sometimes that if the wood's a bit rough, it is worthwhile turning that into 1. And then what the 10.5 is effectively the amount of wood at the bottom that's going to be unmachined. 10.5 is a nice figure for keeping those clamps safe. The clamps tend to stick up about 6 millimeters, and of course there's also the brackets around the back which tend to be about 6 millimeters. So we should be missing the clamps easily by 4 millimeters. So we'll now move on to selecting as tools. We tend to use for these sort of jobs a 6.35mm radius. A nice cutter. It's a very long reach cutter, which is what this sort of job needs. It needs the depth, and we'll also select that for finishing. If you go on the website for the Scale Electrics, you'll discover that there are some quite in-depth alternative tooling to produce extremely high detail molds. All the details are on the actual Scale Electric project in the on the website. But for now we're using the 6.35, and I'm going to reduce the finishing to 10. At 15 it leaves a certain amount of sanding. 10 is a nice finish. If you take it under 5, it's almost finished. You need no sanding at all. But of course it does increase the machining time. Let me explain why the finishing, the percentage and roughing percentage works. That percentage is the amount that the tool moves over between each cut as a percentage of the diameter of the tool. So in other words, on the roughing cut it's going to move over 90% of 6.35. On the finishing cut it's going to move over 10% of 6.35. So if you halve that, you've doubled the number of strokes that it's going to make. But it does improve the finish. There is a point where you can end up overdoing it and achieving no improvement of finish, because ultimately there's only so much finish you can get out of wood. Right, we're moving on to our allowances. This is the distance that the machine will miss the job by when it's roughing. Finishing invariably is 0. Occasionally you might want to alter that. Again, most of the time you're wanted to leave those untouched at 1 and 0. Right, we're now going to go into what's called the footprint control. What this does is it allows us, if need be, to get the machine to run further over the edges, so that if those wheels were very close to the edge of the block and the tool couldn't actually come down, you can actually increase the footprint, so that what happens is that it does machine those edges, and then the machine effectively flies off into fresh air and then comes back. Because we've got enough wood on our material, on our model, we don't need to do that, and we'll combine the model and the base. Right, so we're moving on to our roughing section. This is where we choose the strategy for removing the material at the 90% setting. For the Scalextrics, it is always worthwhile using the raster profile mill in and selecting an angle of 90. What that does is it means that the cutter is working across the model and pushing it directly against the bracket or directly against the clamps. You can add what's called a rest roughing cycle. What that does is it makes the machine look back and at some of the areas that are quite steppy and try to look at removing some of those steps. It adds a phenomenal amount of additional computing, and for what we're doing doesn't actually achieve anything with regard to the finish. On the finishing cycle, what we can do is we can alter again the different strategies for finishing. We're going to leave it on raster, and we're going to choose for this one 45 degrees. We found that 45 degrees works better for car molds. It seems to reduce the stepping to a minimum, but if you are worried about the stepping, you can add compute rest finishing cycle. As I say, it adds a lot of extra machining and a lot of extra computer time, but it will improve the final finish. And the last thing we've got to do now is we've actually got to compute our toolpaths, which we'll press the button compute, and what we'll see is we'll see the computer start looking at the job and working out what areas it has to machine. It's as it runs down the job, each of the layers, you can see it actually physically calculating the layers and calculating where it needs to remove the material. And the last thing the machine does then is calculate the raster finishing. You can see it working out the raster there. The speed that it does this is all based on the processor speed. The faster the machine, the faster it calculates. And having done all that, before we leave GeoCam, we can run a simulation if we wish, where we can actually ask the machine to show us what the actual cutting strategy will look like. Now we can control the speed of the simulation, and here we go, we can actually see exactly how the machine is going to work its way through. And then we move on to the simulation of the raster. We'll stop the simulation there and move on, and we can save the file, the two roughing and the finishing together, or if we want we can save them as two separate files. For our purposes we'll save them together, giving them again the same name as the actual STL file, so that the two match for later. And then, having saved the details, the software will then go through and do a simulation inside the Boxford software. The GeoCam drops away and we actually get to see the machining simulated inside the Boxford software. If there were going to be any problems, such as tools crashing, it would inform me at this stage, and we'd have to go back to the GeoCam and perhaps change the strategy or look at the tooling to make sure that we've got tooling that can actually make reaches as long as this tool's actually been asked to make. So now go across to the finishing, and the final thing it will do when it's gone all the way across is just clean the base up, which means that you get a nice flat base, and that's it. If we now close that down, the model's inside the work zone, ready to press the machine icon and start machining.